Hello everyone, welcome back to our class. Today is class 3 in our course Introduction to the Quantum Computing and Programming. So today we will introduce about the Euler's formula. Okay, the 3 points. First, I will introduce about the Euler formula. What is mean Euler formula and why we need to use Euler formula. The second, we will use Euler formula to calculate some computation on the complex vector. And the third part, we will look more about how we calculate a phase difference between the two vectors. Okay, the Euler formula is very important when we want to transfer between the complex number to the other kind of format. Like we have the first or the second class we already learned about the complex lane, something like this. But that is kind of the complex number. But if we want to transfer to the other kind of format, for example, calculate about the angle, or you can calculate about the moving, or the different speed for complex number is we need to the other way. That's Euler formula can help. Yeah. And okay, we will look. If you see over here, we have very familiar. That's called U, vector U, include about the one part is the real number, and the second part is the imaginary part, or this kind of quote complex number. And we can change to the other kind of representation, like cos or sine. Okay. Actually, we can calculate by this kind of value, okay? Yeah, this kind of value. Yeah, this kind of value. Actually, when we divide this value to this equal to 1, right? This equal to 1. So it doesn't change the total of the value. So actually, this keep, right? Keep the same value, a plus ib, as we see the a plus ib. Yeah. So, but we do this part to make sure, we cannot transfer to the other. So over here, we can calculate. Okay, this one is the square root for a square plus b square. We can equal to the r. Yeah, r the value. And to this one, it can. Yeah, this one is a. Remember, we have a, b, okay? So this is a, b, and this one a. Right? Remember this called a complex plane. This, remember, in the second lesson we already mentioned about complex plane. So over here we have this is this is called theta. Yeah, theta. This is theta. And if the a divided by this value, it equal to cos theta. Okay. And this if the sin theta, psi theta, is equal to the b divided by this value. Yeah, this value. Okay. So that is very important. This is how they transfer. They transfer from the complex vector to the other new form. Is the polar form. Yeah, polar form. So over here we keep this r. This is kind of constant. Yes, constant. And we have I the theta. This one is new. And you will see this guy. And the Euler formula, they use ei theta equal to the cos theta plus I sine theta. This is kind of the new form. If you see from this form, you can calculate by the angle, the relationship between this kind of value to the real and the complex value to the the angle. Yeah. So this kind of very important. Yeah. So I hope you remember about the Euler formula. about the proof of Euler formula is yeah. So maybe you can look slide, but I explain quickly. Euler formula can prove with Taylor expansion. Yes, Taylor. Yes, Taylor expansion. Over here, Taylor expansion, we can F. Yeah. Remember, we have F and this one. So if we have Ex, so if you can move to here is equal to the the xn, right? Xn because E is 0. Over here is equal to 1, right? Yeah, equal to 1. So this doesn't change the total value. About the cos equal to this kind of the formula, the famous formula, and this actually this required to the formula. Maybe you only need to know for now how the cos can equal to the Taylor expansion. So it's kind of the famous formula. Actually, it takes time to tell you in detail, but over here, I hope you remember. If you take care about the proof for the Euler formula, yeah. So this one is remember how it's look, yeah. And about the EI theta. So it's kind of if you can see based on the previous part, the formula with Fn the real, right? So we can have this one is x, or this one is because this is kind of x. Yeah, x. So can xn or this I theta n. Yeah. So the value is equal to this one. Yeah. So this is equal to Euler. Yeah. Euler. This guy Euler formula. That's one of Euler the name for the scientist. Okay. One of the very famous scientist name invent to this kind of formula. So I hope you remember this kind of name. Okay. Okay. Now we have the other way. Based on the Taylor expansion, you can prove the proof Euler formula. Or we have a second way. This this without the Taylor expansion. We still have the other. Actually, this part we base on the integrate. Yeah, integrate. Actually, this part, for example, we can integrate z will be equal to the this one. So this one, I think, is this kind of formula from the high school. Yeah, when you study in a high school, you already learn about how we integrate. Yeah, integrate to the value. So okay, so over here is one very important. I hope you remember. So after we integrate to the value, so we have this and we have this kind of to the value after integration, and when we plus to the this one change the value theta equal to 0, and we can have this kind of formula. This cos 0, so theta equal to 0, right? So cos 0 and I sin 0 equal to the the I 0. Yeah. So, but this kind of value after calculate we can see equal. So C2 is C2 equal to 0. So over here we have this one is 0. So the final value we have I theta, EI theta, so equal to this total. So this Euler formula, Euler. Actually, this is a kind of second method, and for can prove the Euler formula is quicker, is faster. But you need to know about how to do this part. Yeah, this is in high school. I think in high school. Okay, in Euler formula, one of the important part from the Euler formula, you can help you to to multiply the two vector. Yeah, we have a two vector. If we can multiply two vector like vector u and vector v, actually if you see this one is vector v equal to u conjugate. Yeah. And when we use the Euler formula, you can exploit the to transfer from the complex vector or complex vector to the Euler and to the polar format. Yeah. Over here we have for example, we have a u equal this one, so we can transfer like a normal, or based on the Euler formula, so we can calculate about this kind of value. The similar for v, So after we multiply two values, so we can see the total, equal to actually this one, Okay, this one is formula after you addition or subtraction the formula. Actually, I hope you remember this part. And in the high school, you already learned about this part. So I suppose you can remember this part because it's very benefit for you in future when you want to calculate. Okay. For example, the cos alpha plus the beta equal to cos alpha cos beta minus the sine alpha and sine beta. The proof for this part have the next slide. Next slide. So this is how. When you calculate about the e, something like that, you can move to the e alpha I. This is beta I. And if you can use this Euler formula, it is similar when we change like this. And h1 you can use the Euler formula. This one equal to this one, right? Euler formula, and this one equal to this one. And after you multiply, of course you need to multiply the live cos. You can multiply h1, this one, to multiply this one. And the second, you can multiply this one to this one. For example, cos alpha, cos beta, I sin cos beta, Okay, you can multiply and after you combine together, so this kind of value for after you multiply. And similar, when you have this kind of value, so you can combine. Okay, this is you can this value, right? So this is a kind of you can see that we have a real number. This is a kind of real number, and this is imaginary number. So. And you see this kind of corresponding cos, right, equal to this part is a real number, and this kind of sin side alpha plus beta, so that's in the imaginary part, so you can see this, right, this kind of correct. And similar, we have the subtraction, we have a same mechanism, and we can find this kind of value, and we have a similar, we have this kind of we have a 2 multiply the ai, is similar. We can base Euler formula, we can this one, actually this is one is okay, this is okay, this is wrong. Okay, this is AI, not about the minus and beta. This is AI. Okay, because this relates to the alpha. Okay, alpha. Yes. So this after we calculate very similar by previous one. So we can calculate this part and this part. So this is real. This is imaginary part. So after we compare, So this one is. Cos, and this one sin, and the phase difference. Actually, this kind of phase difference, that means we have a two vector. And we need to calculate the difference between the two angle. So this is a formula to calculate, and actually we can calculate the phase difference between the two x based on the divide two vectors. divide two vector, and we can calculate this kind of phase difference. And based upon Euler formula, you can calculate this kind of example. You can calculate the divide two vector, and this kind of the phase difference. The phase difference. Yes, the phase difference. So the phase difference over here we have the pi over 2, and these are 3 pi over 2. And okay, in this lesson I already introduced about the 3 points. The first is about the Euler formula, and I already introduced about how to add, how to multiply, and how to divide. Use the Euler formula, plus. And the last one, we say calculate the phase difference. Phase difference. So that's the 3 points. I hope you can remember in this third class. Okay, thank you everyone.